The Great Cosmic Disappearing Act. How the Yukawa Potential Hides a point charge. Imagine a world where light doesn't just spread out, but is slowly soaked up by the very air it travels through. This is the essence of the screened point charge, a fundamental concept that explains why some forces reach across the galaxy while others fade away almost instantly. The source and the sponge. In a standard electrical field, a single point charge at the center acts like a fountain, spraying field lines out into infinity. No matter how far away you go, if you wrap the charge in a giant sphere, you will find the exact same amount of flow passing through the surface. However, the Yukawa potential describes a much more mysterious environment. At the very center, there is still a point source, a concentrated origin that radiates flux. But the space surrounding this source is not empty. It acts like a distributed sink or a sponge. As the field lines move outward, this surrounding medium systematically eats or absorbs them. Because of this, if you measure the flux near the center, you see the full strength of the charge. But as you move further away, the sponge has absorbed so much of the field that it appears to vanish entirely. A physical mirror. The electron sea. This isn't just a mathematical trick. It is a physical reality in materials like metals or plasmas. Imagine placing a positive charge into a sea of mobile electrons. The attraction. The positive charge immediately begins pulling nearby electrons toward it. The cloak. These electrons don't just crash into the center. They form a dense, buzzing cloud around the source. The result, to an observer standing far away, the positive charge is effectively cloaked. The negative cloud around it cancels out its influence, making the total charge look like zero. Visualizing the invisible. The demos. To truly understand this tug-of-war between the source and the sink, we can look at several visual demonstrations. The fading stream. Imagine cyan dots representing units of flux streaming out from a pulsing center. As they travel through the purple sink of the surrounding medium, they don't just get further apart. They actually fade and become transparent, representing the field being soaked up by the environment. The density shift. When the surrounding medium is very dense, like a thick crowd, the masking happens almost immediately. The screening cloud is tight and narrow, hiding the charge within a tiny radius. The heat factor. Temperature adds a layer of chaos. In a hot environment, the electrons have too much thermal jitter to sit still and form a perfect cloak. This smears the sink, allowing the field to leak much further out into space before it is finally neutralized. Ultimately, this model shows us that the field we perceive is the result of a dynamic equilibrium. The central charge trying to organize the world around it, while the surrounding medium works to hide that influence through a collective, shielding response.